Hello everybody. Today's video is on solving radical equations. Mainly we're just going to be going through a bunch of examples, and as you go through these examples, if you have any questions, make sure you ask me in class. There's going to be ones that I go through with you, and then there's going to be ones that I would suggest you try on your own, and then you can have me check them in class if you need. If you have any questions, let me know. But let's go ahead and get started. The first example that we're going to go through says the square root of 5x plus 1 minus 6 equals 0, and you are asked to solve this. So in this kind of example, the key here is making sure that you get the root or the radical on its own first. And to do that, we're going to have to add 6 to both sides. So we're going to start with that first. And that's going to leave us with the square root of 5x plus 1 equals positive 6. And then you have to remember that a square root of anything is the same thing as writing that x to the 1/2. So if my goal is to get rid of a 1/2 and to make my exponent a 1, we're going to need to take this or raise it to the second power, because a 1/2 times 2 would get you a positive 1, and we want our exponents to always be 1 if we can. So I'm going to take everything to the second power. I'm going to raise it to the second power, and that's going to cancel out my square root and my exponent here on the left and leave me with 5x plus 1, and then 6 squared is 36. And then from here, because we no longer have any radicals, we can just solve like normal. So subtract 1 over, we get 5x equals 35, and then divide by 5, we get x is equal to 7. And you always want to make sure you check your answer, so plug that back in and make sure that it works, because you could have what we call extraneous solutions, where maybe you get an answer but it doesn't actually work for the problem. So here we could check 5 times 7 plus 1 minus 6, it should equal 0, and we get the square root of 36 minus 6. Does that equal 0? Well, 6 minus 6 is 0, so yes, it works. So x equals 7 would be our final answer. Okay? So hopefully that's a pretty basic example. Make sure the square root or any root is on its own first, and then you can solve. Here's an example that you can try on your own if you're not sure, and then you could, of course, have me check that in class if you need it. Okay? So let's move on to the next example. This one's a little bit shorter looking than the last, but notice that it is in exponential form rather than radical form. And either way, it doesn't matter the form, it's the same solving process. So we're going to go ahead and try to get the radical part or the exponential part on its own. So first, let me get my pen. We're going to get rid of this fraction here. So to get rid of negative 2/3, I'm going to multiply by negative 3 over 2 on both sides. And when I multiply both sides, this on the left cancels, and I'm left with x to the negative 1/2, or 1/5, sorry. And then equals, if I multiply here, two negatives become a positive, and my 2's cancel, so I'm left with positive, let's see, 2's cancel, so I'm left with positive 3. Now to finish this problem out, I want to get rid of my negative 1/5 exponent, and to get rid of a negative 1/5, I'm going to raise all of this to the negative 5th power. So it's going to look like that, and then I can go ahead and reduce. So negative 1/5 and negative 5 will cancel out to get you x to the positive 1, which is good, and then I'd have 3 to the negative 5th. From there, remember, we don't want to leave negative exponents, so this goes back to our exponent rules. Negative exponents make the whole answer flip and become positive, so we'd have x is equal to 1 over 3 to the positive 5th, which is going to be the same as x equals 1 over 243. And just like normal, you want to make sure that you plug your answer into the original equation and see if it works. So if I do that, I have negative 2/3 times 1 over 243 to the negative 1/5. And if done correctly, and if the answer is not extraneous, it should get you negative 2. That's why I put a question mark there, just so we can make sure that our answer indeed does get us negative 2. So I could go ahead and simplify, do the exponent part first. That's very important. And if you do that in your calculator, you're going to get a positive 3. And negative 2/3 times positive 3, does that get us negative 2? Yes, it does. So this answer works. Okay? Always check your answers, extremely important. Now this next example down here, very similar to the first one, but notice that my exponent's a little bit different. So rather than a 1 over a number, I have a 5 over a 2. So the same rule applies. To get rid of the exponent, you have to take it to the reciprocal power. So I'm going to let you try this one, but to get rid of this exponent here, you're going to want to take everything to the 2/5 power. So be careful, because you want to cancel these out, and to do that you have to take the reciprocal. So on the left side you're going to be left with the x plus 3, and on the right you're going to be left with 32 to the 2/5, and then you're going to have to know how to reduce that. Don't forget that when you have a number to a rational exponent, you could rewrite it as the 5th root of 32 all squared. That's easy, because then you can reduce this and then square it. Same thing, and then that's the number that's going to go here, and then of course you can solve. So if you have any questions on that example, make sure you let me know. Alright, 2 more examples and then we'll be done with this section. This next one here, it says the square root of x minus 6 equals x minus 8. Just like that first example, you're wanting to get rid of the radical, and the good thing on this one is that the radical is on its own on the left side. So now we just have to start eliminating. Remember, we want to get rid of a radical by taking it to the reciprocal power. So in this case, a square root would be canceled by taking it to the 2nd power. So I'm going to take this square of both sides, and that's going to cancel everything here on the left and leave us with x minus 6, and then over on the right side we're left with x minus 8 squared. Now this is the part where this example is different. When you have x minus 8 squared, remember you have to FOIL. So you could either write out x minus 8 twice and then FOIL it that way, or if you remember the trick, you can square the first and that gets you x squared. You can multiply all 3 things together, so x times negative 8 times 2 gets you negative 16x, and then you could take negative 8 squared, and that's going to get you 64. But the key is that you make sure you do not forget the middle term. It is not squaring the first and squaring the last. You will miss points on that if you forget the middle term, so be very careful. So this is what's going to look like once we've FOILed, and now we just have to start solving. Remember, when we solve a quadratic, that's something with x squared in it, then we have to get everything to one side and make it equal to 0. So I'm going to subtract x over and add the 6 over. And when we do that, we'll get 0 equals x squared minus 17x and then plus 70. And now I have to think about how to solve a quadratic. So remember, you could either do quadratic formula or you could graph. Graphing's not the most efficient, but it is possible. So you could graph and see where it hits the x-axis, or you could factor. Those are the 3 main ones that I would suggest. The 2 main ones that are probably going to be the best in this particular section would be quadratic formula or factoring. And in this one, it actually is factorable, so we're going to go ahead and factor it out. So our factors for x would go x and x here, and our factors of 70, so we know 70 would be a 7 and a 10. They could add to get 17 and multiply to get 70. So we're going to have 7 and 10 there. And then we're just going to have to figure out our signs. They're both going to be negative. So there's the factored form, and now I can set each of these equal to 0. So x minus 7 equals 0, and x minus 10 equals 0. And when we solve, we get x equals 7, and we get x equals positive 10. Now the key here, just like I've mentioned before, is you have to check your solutions. So when you check your answers, plug them back into the original and make sure they work. If I do that, so I'll do that over here in this purple color, I get the square root of 7 minus 6. It has to equal the same thing as 7 minus 8. So the square root of 1, does it equal negative 1? Well, in this case, we're always talking about our principal root or our positive root, and that's going to get you 1. So 1 is not the same as negative 1. So positive 7 is an extraneous solution. So we would make sure that we write that. So it's an extraneous solution, which means it does not work. Now we want to try with 10. So if I plug 10 in, I get the square root of 10 minus 6. Is that the same thing as 10 minus 8? Well, the square root of 4 is 2, and so you get 2 equals 2. So that means that 10 works, but 7 does not. That's why it's very important to make sure you check your answers. And if you were to graph this, you would see where 1 works and 1 does not. Okay, so it's very important. The next example below you can try on your own, same concept. Be careful with the square root of x here because you're going to have to FOIL things out and you might get rid of that square root, so be very careful. And then the last examples, the way I could show you this is just to show you that graphing is another acceptable way of solving. Especially if you have your computer, you could plug in these equations into Desmos and then see where they cross, and that would be your solution. So for example here, let's see if I pull up Desmos, you could have the square root of x, y equals the square root. And then you could also type in y equals x minus 2. They're two separate graphs, and we want to know where they equal each other. So type them in separately, and then see where they cross. Well, in this case, they cross right here, and at the point 4, 2. So your solution for x in this case would be x equals 4. All right, so you could write this, that x equals 4. And you could always plug it in and see if it works. Square root of 4 equals 4 minus 2. Well, 2 does equal 2, so that works. Okay, so graphing can be really quick if you have your computer because you can just type in the equations, see where they cross. This other example that I have here, we have x minus 1 to the 2/3, oops. And then we have negative y equals negative 3. If you see where those cross, notice that this doesn't cross at all. So in this case, because these graphs will never touch, this would be one where there is no solution. And it is possible to have a no solution. It won't always happen, but that's if your graph doesn't connect at all. Okay, so any questions on the graphing, let me know. I can show you how to use Desmos. But that's really it for today. Thanks for listening.